Welcome back from break. We're going to start with a talk about exponents. You'll notice that we're in chapter 4, kind of an earlier chapter, so the concepts here are going to be a little bit more going back to basics. You've dealt with exponents before. I know that you know something like 7 to the 4th represents 7 times 7 times 7 times 7, and that this number represents something that we could call the number of times that you multiply something by itself. But I want to go to something that's even more fundamental when it comes to algebra, and that's this concept up here. Is a plus b squared the same as a squared plus b squared? In math, when you want to prove something is not true, and this is going to be a not true, you can show by plugging in two sets of numbers. So we're just going to pick some numbers. We can let a be equal to 2 and say that b is equal to 3 and see if it works. If it works all the time, it should work when a is 2 and b is 3. On the left side, we get 2 plus 3 squared, and what we're asking is that equal to 2 squared plus 3 squared? If that is equal, well then, on the left side, order of operations says that we do 5 squared, and on the right side, we get 4 plus 9. 5 squared is 25, and 4 plus 9 is 13. Those are not equal, which means that this not equal carries back all the way back to the original thing. And so, is this always true? The answer to that is no. This is also called a proof by counterexample. What a counterexample is, was a single example that showed that it's not true, and so you can say that it's not true all the time. Now, it could be true 1 or 2 times. If a is 0 and b is 0, that's called a trivial example, but this is not always true, so we can't say that a plus b squared is a squared plus b squared. Some definitions now. This here is called the base, and this is called the exponent, or the power. We use both words. We probably use the word exponent more. And then if I go down here, our order of operations says that this happens first, where x is the base, and 4 is the exponent, or the power. So what would 9 be? Well, 9 is not being raised to the 4th power. 9, that's actually a 9 times. That's called a coefficient. Those are words that you should know. So we have base, we have exponent, or power, and we have coefficient. Moving right down, we start with something like 6z cubed, and what I want to do is compare this 6z cubed with this, just to highlight the differences, because in the first case, your base is 6z, because that is what is being raised to the 3rd power. Grouping that in parentheses shows that that's what we want to raise to the 3rd power. So we kind of move it off and say that that's the same thing as 6z, 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 which means 6 times 6 times 6. And we can actually prove, going from here to here, that this property, the two properties we're using are the commutative and the associative properties to regroup and reorder the stuff around. 6 times 6 times 6 is 316, z times z times z is z cubed, and we get 316z cubed. But in this example, 6z cubed written like this, it's only the z cubed that is part of the base and exponent system. So we still have a 6 and z times z times z, and strictly speaking, we didn't really need to write it like that. 6z cubed was the most simplified, whereas on the top one, 316z cubed was the most simplified. Okay, moving down, what are the order of operations? This is crucial to know, and we have talked about this a number of times. We start with the first step. I'd like to call this groupings. I'm also going to start maneuvering and calling them functions. Anytime that things are grouped because of something that's happening. But really it's about groupings right now. Grouping symbols such as parentheses and the numerator and denominator of a fraction bar. We have radicals, which we'll be getting to a little bit later. We have the left and right side of an equal sign. I have these kind of little something equals something else. And inside those dotted boxes, we always want to simplify. Those are groupings. Step 2 is the one that we're highlighting now. It's our exponent. We had another one. It was exponents or roots or radicals. But we're mostly focusing on the exponent parts right now. Step 3 was the plus minus left to right. Oh, sorry, not plus minus, multiplication division. Okay. Multiplication division left to right. And step 4 was addition subtraction left to right. So the examples that we're going to do follow a few things. One of my suggestions would be to kind of pause this video, work maybe about 3 or 4 of these ahead, and then kind of resume it and see what you got. So why don't you go ahead and pause it, work on the first 4, come back to me. Number 1, we have negative 3 to the 4th power. This negative is actually a negative 1 coefficient times 3 to the 4th power. That's how you'd be thinking about it. 3 to the 4th power is 3 times 3 times 3 times 3, or 9 times 9, or 81. So this is really a negative 81. Now, I would expect you to be able to go from here to here without all those steps. I just want you to see that the negative 1 is a coefficient. Number 2, this is really negative 3 times negative 3 times negative 3 times negative 3. 4 negatives makes a positive, and 4 3's multiplied together make an 81. So that gives us positive 81. Again, you should be able to go from the right to the final answer without much work, or without showing a lot of work. Number 3 and 4 you really should do before you kind of do this. If you haven't already, pause it, do these two. But there's a difference between numbers 3 and 4. Number 3, 1 minus 6 squared. The order that I would do this would be 1 minus 6 is negative 5, and negative 5 squared is negative 5 times negative 5, or positive 25. Number 4, if we follow order of operations, it's 1 minus a 36, which is negative 35. Okay, again, pause, do 5 and 6. 5 follows the order of operations. If I look, I've got 5 squared, so I have 2 times 3 minus 25. Then we do the multiplication. 2 times 3 is 6 minus 25. 6 minus 25 is negative 19. Number 6, I'm going to do the groupings first. 3 minus 5 is negative 2. Then I'm going to go exponents. Negative 2 squared is positive 4. And then I'm going to do 2 times 4, or positive 8. Number 7 is a longer string of these, so we have to kind of follow and make sure. I'm just peeking ahead at number 8. Okay. Follow and make sure we're doing the order of operations. So when I look for groupings, I see this, this, and this. And I'm going to do what's inside those first. Meanwhile, I might as well make the 3 squared become 9, because that's not going to affect the rest of the problem. So I have 9 divided by, I get 4 minus 3. Minus, then I have 25 minus 9 divided by, and I can go ahead and do the negative 2 cubed for the same reason that I did the 3 squared. Negative 2 cubed is negative 2 times negative 2 times negative 2, that is negative 8. Then I'm going to do the groupings and simplify those. 9 divided by 3 minus 25 minus 9 is 16. Then divided by negative 8. Next, I look for the multiplication divisions. I've got a division here, and I have a division here. So 9 divided by 3 is 3. This minus is going to hold. 16 divided by negative 8 is negative 2. 3 minus negative 2 is 3 plus 2. 3 plus 2 is 5. Evaluate means plug in, so we're going to do our substitution step first. 2 times 3 plus negative 2, all in parentheses and all squared. Follow the order of operations. 2 times 3 is 6. 6 plus a negative 2. 6 minus 2 squared. 6 minus 2 is 4. And 4 squared is 16. Number 9, same thing, substitution. Negative 1 minus a negative 2 cubed over 2 times negative 1 plus a negative 2. Clean that up by looking inside the grouping symbols first. 1 minus a negative 2 is the same thing as negative 1 plus a 2. Denominator, I have 2 times negative 1, or negative 2, plus negative 2 is actually minus 2. And remember, I'm actually looking at the denominator and simplifying that because the denominator is its own grouping symbol. Negative 1 plus 2 is 1, so I have 1 cubed. Negative 2 minus 2 is negative 4. 1 cubed is 1, so that's 1 over negative 4, which is the same thing as negative 1/4. Okay, let's move back. We got some more definitions. Polynomials. Let's start with monomial. First of all monomials are polynomials. It's just kind of a terminology thing. But a monomial is a product of variables and constants. So, little sub-definition, let's kind of move down here. What's a constant? Constant is a number whose value never changes. A number whose value never changes. The number 3.5's value will always be 3.5. It will never change. The number 0 will never change value. The number negative 1/2 or the square root of 7, those are all constants. In fact, any number on the number line is a constant. So why does it get confusing? Well, the number pi is also a constant. It's a representation of a number that's really hard to write out. Just like radical 7 is a representation of a number that's really hard to write out. Radical 7 doesn't tell you where radical 7 is on the number line. You'd have to think, what is the square root of 7? Square root of 7 is somewhere in between the square root of 4, which is 2, and the square root of 9, which is 3. So you kind of know it's going to fall somewhere between 2 and 3 on the number line, just like you know that pi is about 3.14159, and we know its value. But opposite of a constant, I'm trying to see if I have it here. I don't. So let's put it over here. The antonym of a constant would be a variable, which we say back up here. So an example of a monomial is something like 7x squared. Another example of a monomial is the number 3. Another example of a monomial would be 14x squared y. Those are products of variables and constants. Negative 1/2 z to the third. All of those are monomials. There is a number that is not a monomial. 0 is not a monomial. We don't consider 0 to be monomial. Because when it comes to polynomials, 0 is the absence. So what's a polynomial? Well, poly means more than one. So polynomial are one or more monomials joined by a plus or minus. So if I take any of those from above and join them with a plus or minus, 7x squared minus 3, that is a polynomial. I could take them all and just keep adding some of them. 14x squared y is a polynomial. Polynomials don't have to be simplified, but typically they are. If I do 2x cubed minus another x cubed, that can be simplified to x cubed, but it's still a polynomial. It's actually a monomial. All monomials are polynomials. I wrote that in red. I didn't want that to be confusing, but that's okay. The 0 is not a monomial. It's not okay. Let's go down to binomial. Binomial is a polynomial. Sorry, I'm still in red, but this is all good. A polynomial with two monomials. In fact, there's another name for monomial, so let's pop back up to monomial. Monomial has a synonym, and that synonym also called terms. This is very crucial because in a polynomial, terms are separated by pluses and minuses. So a polynomial with two monomials, aka two terms. So something like x plus 7 is a binomial. It can't be simplified any more than that. And yet, if I gave you something like 6x squared minus x squared, that is not a binomial, because that could be simplified to a monomial. A trinomial is also a polynomial with three monomials. I'm just going to underline that tri and give an example. If I said 6y squared minus 4y plus 2, that is a trinomial. So I'm going to move this little example here down one. Maybe remove some of the things, or some of the X marks here, because this was an example of like terms. Terms with the same variables to the same exponents. Terms with the same variables to the same exponents. Those are like terms. Another important feature of polynomials is this thing called a degree. The degree of a monomial, monomial meaning one term, but the degree of a monomial is how many variables. This is something that people often find very confusing, and it's really just a definition thing. So I'm going to give you four examples: 7x squared, 3xy cubed, 9xyz, and negative 15. Those are all monomials. How many variables are present? 7x squared has 2. I shouldn't put a minus there. I'm just going to put a little 2 here. 3xy cubed, there's 1x and 3 y's, giving you a total of 4 variables. 9xyz, there's 1x, there's 1 y, and there's 1 z, giving you a total of 3 variables. And negative 15 has a total of 0 variables. Something important here is that these exponents are always going to be positive, and they're not going to be fractions, so we're not really going to mess with anything like that. Okay, degree of a polynomial. So if I took any of these from up above, like the 7x squared, and I did like a minus 3xy cubed, so I took two of the monomials and I subtracted them, which is how we kind of create polynomials. Well, I know that this monomial has a degree of 2, and this monomial has a degree of 4. I want you to think of the degree of a polynomial as being like a trump card, if any of you play euchre. Whichever one is the biggest is the one that we're going to go with. So we're going to say that the degree of this polynomial that I've created has a degree of 4. Let's do some practice with this. Number 10. There's no plus or minus in number 10, so this is a monomial. Because it's a monomial, we look at the degree of, we look at how many variables there are. 2 x's, 1 y, 4 z's. That gives us a total of 7. The degree of that monomial is 7. 11 is a monomial. If it's a monomial, we have ABC, that's 3 variables. 12 is a monomial. X to the 5th, y, z to the 4th, that's 10 variables. 13 is a monomial. I know this is getting boring, but just bear with me. Got one variable. 150 is a monomial. with 0 variables. N squared p squared is a monomial with 4 variables. 16, 3x squared minus 8x plus 5 is a polynomial. It's not a monomial, it has more than one. So what we do is we kind of look at all 3 parts. This is a degree of 2, this is a degree of 1, this is a degree of 0. So its total degree is actually 2. We don't add them up. We just take whichever one's the biggest one. 17 is a polynomial. This is a degree of 3, this is a degree of 4, 7, and 4. We're going to go with the 7. 18 is a poly, degree of 4, degree of 5, so the total degree is 5. 19, it's a poly, so the degree of 3 and the degree of 6, and we're going to go with the 6. Moving on, simplifying. We've done these before, we just have to look for like terms. Which means we're going to take a step, we're going to distribute the negative first. So I'm going to rewrite the whole thing, u cubed minus 3u squared v plus 2uv squared minus 3u squared v plus 2uv squared and plus v cubed. All I did was distribute the negative. Then we're going to look for like terms. There's nothing matching the u cubed. The 3u squared v is going to add with the other u squared v. And then the uv squared are going to add together. Be really careful. Check your coefficients, check your negatives. We end up with u cubed. Negative 3 plus negative 3 is negative 6 u squared v. Then we end up with plus 4 uv squared. And then finally, plus v cubed. And that's my final. 21, we're also going to simplify. 2p squared cubed minus 3pq squared plus q cubed plus p squared q minus q cubed. Look for like terms. Q cubed doesn't have it. Looks like the only one would be this and this. So everything else, but I'm actually going to do, oh wait, we've got the q's. Forgot about those. Those two are going to match as well. So I'm actually going to put it in descending order with 1. Let's go with the p's. Let's do the sum here first. 4p squared q. The q cubes drop out because it's q cubed minus q cubed. And then the other ones are going to add to become a negative 2p q squared. Solve. Simplify the left and simplify the right. 3n minus 6 plus 2n equals 4n minus 12. So then I end up with 5n minus 12 equals 4n minus 12. If I add 12 to both sides, I get 5n is equal to 4n. Subtract 4n from both sides, and I get n is equal to 0, which is a perfectly acceptable answer. Distribute. I get 2y minus y squared equals 6 minus y squared minus 3y plus 4. Let's simplify the right side. Negative y squared minus 3y, and I'd have plus 10. Okay, if I added y squared to both sides, I have 2y minus, or equals, negative 3y plus 10. Add 3y to both sides, and I get 5y is equal to 10. Divide both sides by 5, and you get y is equal to 2. Finally, 24. 3 minus 2x squared plus 2x equals 3x minus 2x squared minus x plus 3. I'm going to put things in descending order. Negative 2x squared plus 2x plus 3 equals negative 2x squared. I have like terms that can add to give us a negative 2x and then plus a 3. Or sorry, positive 2x plus 3. If we look at the left and right sides, these are both the same thing, which means I'm going to end up with 0 equals 0 when I add and subtract everything off from both sides. This is true, which means that my solution for x is all real numbers.